In the previous module, we defined two kinds of implementability. One is the indirect implementation, which we call dominant strategy implementable. The social choice function was dominant strategy implementable using an indirect mechanism. And the other one was a direct mechanism, which is dominant strategy incentive compatible. Now in this module, we are going to discuss a result which actually shows the relationship between these two. And the relationship is very direct. This is known as the revelation principle for dominant strategy implementable social choice functions. It says that if there exists an indirect mechanism that implements F in dominant strategies, then F must be DSIC. So even the direct mechanism should also be possible to implement. And that is a very remarkable result that what is the implication? You can now focus entirely on these DSIC mechanisms, and that will be without loss of generality. We don't really need a really roundabout way of implementing F using indirect mechanisms. So let us look at the proof. It is very simple and straightforward. So it is saying that the function, the social choice function F is implementable, dominant strategy implementable. So there must be some indirect mechanism given by this such that there exists some function mapping, the message mapping, which takes this capital theta i's to capital M i's, such that you have for all these players and for all these strategies of or all these messages of other players, this SI theta I must be a dominant strategy. So this is the definition. So if you just replace this with MI and compare this with the definition of dominant strategy implementability in the previous module, you'll see that this is the same thing. So we have just replaced that MI with SI theta I, and this should hold for all M minus I tilde, for all the messages chosen by the other players, for all MI prime, and for all theta I. Right? So this is the first equation, first inequality. And that is not all, because this is implementing the social choice function. Therefore, the outcome of this G applied on those strategies must be equal to the outcome of the social choice function itself, and that should hold for every theta. Right? So this should hold for all theta in capital theta. Now, now we can just do some clever substitutions. So because this the first inequality is holding for all Mi prime and M minus I tilde, we are going to look at this in particular when Mi prime is Si of theta I prime. So you imagine that player I is choosing a type which is not his true type, but a different theta I prime, and you apply the same Si on that, you get some message which could be different from Mi. And therefore that is the Mi prime that we are going to consider. And similarly, you can think of the M minus I tilde to be these functions. So this is a tuple of all the functions of all the players except the agent I, and they are you are picking those at some type profile which is theta minus I tilde. Now this theta I prime, as we said, theta minus I tilde, they are completely arbitrary. You can pick anything. So upon substituting, what you get as one is nothing but this inequality here. And now we notice that because we have assumed that this G, so from this equation 2, we know that this is going to be exactly equal to f of theta minus I tilde. And this part will be f of theta I prime theta minus I tilde. This is coming due to 2. This inequality should also hold. And that is nothing but the definition of DSIC. So just by careful substitution, we found that if there exists a social choice function which is implementable via an indirect mechanism, dominant strategy implementable via an indirect mechanism, then it must also be dominant strategy incentive compatible. So in a schematic way, what you can think of this as the center of this diagram is the indirect mechanism, which is taking only inputs in those message spaces and deciding these G's. And there exists a strategy which is taking the true types of the players and transforming them into this message spaces. and the indirect mechanism is taking those messages as input and giving the same output which they should have got if they were implementing the direct mechanism. So this dotted line here is showing that this representation is equivalent to look at the whole mechanism as a whole. You forget about this internal dynamics here. Rather, you ask the agents to report their types directly. You act directly on that. So this whole direct mechanism is taking these types as their inputs, implementing the decision function of f, which is the social choice function, and that will be the outcome. And if there exists some G and this message space is M, which will implement this in dominant strategies, there must also exist a direct mechanism. So we can, without loss of generality, forget about this indirect implementation altogether. We can just think about the direct mechanism f of theta without loss of generality. So this is a very important result, because this gives you the flexibility of working without any indirect mechanism. Now, once we have talked about the dominant strategy incentive compatibility or dominant strategy implementation, it's very natural to talk about the Bayesian extension. So maybe the agents, so in the previous case, the guarantee was very robust. Agents could pick anything. I mean, their choice of revealing their type truthfully is independent of whether the other player is revealing their types truthfully or not. But there are some cases where agents may have some probabilistic information, some belief about others' types. Once I observe my type, I may get some amount of information about the others' types. So there the Bayesian extension comes in. This comes from the standard setup of Bayesian games. So these types are generated through a common prior, and this common prior is a common knowledge, and they are revealed. The types are revealed individually only to those respective agents, right? And this is exactly the Bayesian game setup. And what is the Bayesian game? We have represented a Bayesian game using this notation. This is the set of players. There was this set of actions which are now replaced by this message spaces. So that is the actions that the players can now pick. Type sets are as before. There is a common prior which is given by P, and once this is done, and for every type profile there exists a normal form game which is given by this gamma of theta, right? And the strategy for player I, or the message mapping for player I, is given by this function Si, which maps this theta I into that message space or the action space. Now we say that an indirect mechanism M1 to Mn comma G implements the social choice function f in Bayesian equilibrium as before, if there exists a message mapping S1 to Sn such that this Si of theta I, this particular action here, maximizes the X interim utility of player I. So we know what is an X interim utility. So this is when you observe your own type, player I observes his own type, and he takes the expected utility by expecting over all the theta minus i's, because the given theta I, he has some modified belief about this theta minus i's, and he takes this expected utility, and that is going to be larger than any other mi prime. So this Si theta I is going to give him a larger expected utility if he reports mi prime. And notice that the difference with dominant strategy is that we are now talking about a profile, not individual SIs, because this is kind of a Nash equilibrium kind of a setup where everybody else is picking the same S minus I. Then it is meaningful for agent I to stick to SI. If they pick something else, then we don't know. This is only guaranteeing in the form of an equilibrium. And of course, this is the condition of the utility. It should also satisfy the same indirect mechanism should also implement the social choice function. So therefore, at the equilibrium point SIS minus I, this inequality, this equality of the outcome should get satisfied for all theta. In that case, we'll call this mechanism, this social choice function f, to be Bayesian implementable via this indirect mechanism. And of course, because this is a Bayesian implementability, we'll have to also mention what is the prior. So this is implementable under this prior of P. Now it is not difficult to see that if you have a social choice function which is implementable in dominant strategies, then it must be Bayesian implementable. The intuition is quite simple. You have in the dominant strategy, you have a much stronger condition. No matter whatever is the type of the other players, or whatever is the strategy or message picked by the other player, your SI theta I is going to be a dominant strategy. But if you weaken that condition by expectation, so when you are talking about the equilibrium only in expectation over this theta minus i's given theta I, then of course that is going to get satisfied, because you have already satisfied the inequality in the dominant strategy for all possible m minus i's. So I just leave this this task as a homework, but this is very straightforward to show. Now, like the dominant strategy incentive compatibility, we can say that this direct mechanism theta 1 to theta n comma f is Bayesian incentive compatible if you have the same inequality, but now you are taking the expectation with respect to theta minus I given theta I. So this is the x interim utility of player I, and you are taking that x interim utility, and that is getting maximized when player I is revealing his type truthfully versus revealing something else, theta I prime. Now a very similar result like the dominant strategy implementable social choice functions holds here as well, and this is called the revelation principle for Bayesian implementable social choice functions. So the statement is very similar. If the social choice function f is implementable in Bayesian equilibrium via some indirect mechanisms, then f is Bayesian incentive compatible as well. And the proof idea is exactly similar to DSI, just you will have to now work with the expectations instead of the direct utilities. So I will also leave this as a homework exercise. So these two results are actually saving us from searching over all possible indirect mechanisms. So for the truthfulness of these two kinds, we will only consider the incentive compatible mechanisms. We will only consider direct mechanisms, and we'll discuss whether they are implementable in that direct mode or not. So even though we have proved this results using cardinal preferences, the same argument with a minor modification will still work.